All right, so let's go. We need to very quickly cover trigonometric derivatives and move on. Okay, so you all remember how the graph of sine, cosine, and stuff like that look like. This picture illustrates that sine of x is not an invertible function. To be invertible, it means that every input has a unique output, but you have several inputs, and they produce the same output. And that's the horizontal line test. Do you understand the meaning of the horizontal line test? It means that you see where you see those blue stars? Those blue stars are all mapped to the same value y. So I cannot find the inverse of that particular green point on the y-axis because it has several, in fact, infinitely many inputs that produce it. So that means that sine is not an invertible function. You with me? Right? And so what we can do is we can define a function which we stop using that symbol, but let's for a moment use capital sine. Capital sine is the restriction of sine from minus pi over 2 to pi over 2. And between those two numbers, the function is invertible. You can see I drew the red curve here, right? That's it's called a branch, an invertible branch of sine. So it covers all the range of sine, but the domain is restricted to make the function 1-to-1. Yes? Understood? So this is an invertible function. And I hope you understand that sine and sine inverse, they have the same graph. And that means that the properties of those functions are very much related, especially when you talk about differentiability. If sine is differentiable, obviously sine inverse will be differentiable because you are talking about the same curve and only modify your perspective on the slope of that curve. Good? So let's first, before we go on and talk about it, tell me what is sine inverse of 1. In other words, we're asking, if you apply sine to this angle, you get 1. So sine inverse of 1 is an angle in radians. You understand? The sine minus 1 means it will cancel. If you apply sine, it will cancel one instance of sine. So what is sine inverse of 1? In other words, what value will sine map to 1? When is sine equal to 1?
Can you repeat the question? I didn't catch it.
Yes, the question is, what is sine inverse of 1? And so to understand this question, simply ask yourself, what value does sine map to equal to 1? Yes? And the answer is obviously pi over 2. We don't, it's when I say sine inverse, I'm asking this. From what angle between pi over 2 and minus pi over 2 do I get the value 1? So sine inverse of 1 equals to pi over 2. Yes? Now, what is sine inverse of minus 1? It's very similar. Sine inverse of minus 1 is minus pi over 2. Right? Only the fourth quadrant here gives us negative values. You understand? Now, what's sine inverse of root 2 over 2? Help me with that one. In other words, that is asking what angle in between minus pi over 2 and pi over 2 produces root 2 over 2. Okay, Alan, the answers are supposed to be in radians, right? Degrees are very arbitrary, and no person of any good repute will be using degrees when they do calculus. Christian, why have your face fallen?
I'm trying to think how to do this properly.
What properly? You're just guessing. You're saying I am an angle that if plugged into sine gives me root 2 over 2. That's what this expression means. Why? Because sine inverse means apply sine to it and you get root 2 over 2. The sine with the -1 means cancels. I cancel one instance of sine. That's the -1 thing, you understand? Under composition, I cancel one instance of sine. So what angle gives us root 2 over 2? Remember the square? Take the square, cut it in half, you'll get root 2 over 2. Speaking of which, don't forget, before we leave today, there will be a question that you will have to answer: from what, when, where. Right? If you haven't known what it is, it's a great Russian show. Right? And this would be related to this thing possibly. Okay, we'll see how it is. So the answer is pi over 4. The answer for C is pi over 4. Because you have to remember, not remember, you can construct those angles. We have pi over 2, pi over 4, pi over 3, and pi over 6 are the values that we know how to deal with. Okay? So then we have sine inverse of -1/2. That will be simply minus pi over 6. Sine inverse of minus root 3 over 2 will be minus pi over 3. Okay, how we know those angles? If you are confused and would like to review, after class, I can go into that again. Okay, I cannot stop since I need to be in integration as fast as possible, or we are done for. Good. Now, yes. Now, sine inverse of 5 is impossible. There is no angle that gives us anything bigger than 1 or smaller than -1. So that's, as Alan is saying, it's a domain error. It's impossible. Exactly, Alan. Beautiful. Okay. So I hope that what I said is something familiar to you guys. You see, this is what I mean. It's what they call pre-calculus. It's something that you're supposed to know from before, but I also reviewed it. Right? You remember, that's one reason that we are so slow. Again, after class, we can talk about the entire thing. So here are the corresponding restricted domains for cosine, secant, tangent, and cosecant. I wrote them purposefully with capital letters to indicate that's not the full function, but a function involving a restricted domain. Good? Now, here is this question, guys. Can you do it without me showing you how? Take the derivative of sine inverse of x. What will that be? Right? Can you figure it out without my help? You have 3 minutes. Minus cosine, minus, not quite. So how do you solve this, guys, right? So first of all, well, there are many things you can do. Let me give you another minute. The minute is over, and this is a simple trick that you can do. So you say y equal to sine inverse of x, right? this simple thing, y equals to sine inverse of x. And that means that if I apply sine to both sides, sine of y is equal to x, and I can apply implicit differentiation. So I will say derivative of sine of y is cosine y multiplied by y prime. And the derivative of x is 1. So that means that y prime is equal to 1 over cosine y. Now, would anybody possibly tell me why is there a 1 over cosine y? Right? Why do I have a cosine and why do I have a 1 here on the numerator? Do you see that? And do you understand my question? I will explain my question a bit better once I see what you, because of the negative power. I'm not sure what you mean by negative power. Where do you see negative power, Brandon? Do you understand my question, guys? Derivative of x is 1. Yes, that's algebraic. I will explain in a moment what I think is troublesome about how you answer those questions, or this question, or how you do not answer it. Why is there a 1 and why is there a cosine on the bottom? Do you understand my question? So you might see the algebra, right? The derivative is cosine y, y prime, and I can solve algebraically. Anybody, anyone else? Anyone else? Any ideas? Here is the type of question that I'm asking you guys. I'm asking, why are the eyes of this person below his nose? Right? That's the type of question I'm asking. Why are the eyes of the person below his nose? And then you say, because his eyes were carried out or something like this algebraically. But the answer is very simple, because the person is upside down. Yes? You have to recognize if the eyes are located below the nose, maybe the person is, can I turn like this? Upside down, right? And the reason that when you're not answering it, that means that's not understanding. That's the problem. That's where I want you to get. You understand? Not answering this is not understanding that the person is upside down, the same person. Why is there 1 over cosine? Because sine inverse and sine are the same graph, the same shape. But what happened here is, why is there a 1? Is because I see inverted slope. Derivative of sine is cosine. That's what I see over here, right? 1 over, it's because up is to the right and to the right is up. I switched places, right? Dy dx as opposed to dx dy. That's geometrically the reason, okay? It's okay, you can do it implicitly, but I'm trying to explain to you what my questions are, what I'm trying to encourage for you to just see what's happening here. So it's 1 over cosine y algebraically, but it's deeper if you understand geometrically what's happening. It's just 1 over the slope that would have been computed were you to find the derivative of sine. Yes? And then what is cosine of y? This is cosine of sine inverse x, because y is sine inverse x. And then it's not polite to leave the answer like this, since you can simplify it. What happens if I apply cosine to something that I know what would happen to if I apply sine? So here is how I can solve this. Look at it, guys. Sine inverse of x is a what? It is an angle. You see, when I say it's a what, you can say it's a letter. It's sin minus 1x. The letters don't matter. Sine inverse of x, it's an angle. And if you apply sine to it, you will get x. That's what sine inverse of x. It's the angle that if you apply sine to, you will get this input, the x. Good? And what happens if you apply sine to it? It means if you put it on a right triangle, sine is always opposite over hypotenuse. So the easiest way to get x is to set opposite equal to x, hypotenuse equal to 1. Yes? So that means that we have a triangle with x and hypotenuse equal to 1. And then by Pythagorean theorem, the remaining side is root 1 minus x squared. So if I apply cosine, are you following me, guys? if I apply cosine, what do I get? I get adjacent over hypotenuse. I get root of 1 minus x squared. So I know that cosine of sine inverse of x is root 1 minus x squared. Clear? Don't look at me sad, right? It's clear, correct? It's exciting. Math is happiness. Math is a reason to exist when everything else fails. You know, I sometimes feel very terrible, and then I look at my books and I think, well, before I die, at least I will read those books, right? Of course, when I read them, it's not going to matter. You know, it's going to be all in the past. But I look at it, I want to understand some interesting ideas, or at least ideas that appear to be interesting. I want to touch them. I want to catch this firefly before I'm gone. Good? So that should be you with me, right? And that's why after the semester is over, we don't stop. We continue talking about calculus and other things, yes? In preparation, maybe we talk about probability. In preparation for you sitting on my probability class. Since, of course, COVID is forever. We're not ever returning to normal. You know that, right? If you don't, I'm not sure. Right, so anyhow, good. So the derivative of sine inverse is 1 over cosine sine inverse of x, which makes 1 over root 1 minus x squared. Do you understand? You bet you should understand that. And now your turn. Please find the derivative of cosine inverse. Go ahead. Calculate the derivative of cosine inverse. You have 3 minutes. Nassim, very good, and only simplify it if you can. Yeah, I want you to find derivative of cosine inverse, Christian. Exactly that. Yes, you said the same thing. time. So yes, Christian, that's good, but simplify it. Let's simplify it. Otherwise, it's good. So I set y equal to cosine inverse of x. Apply cosine to both sides. You see, just this little detail, it already is a long way to solve this problem. Y equals to cosine inverse x, apply cosine to both sides, and you get cosine of y equal to x. The derivative of cosine is minus sine, so you have minus sine y multiplied by y prime is equal to 1. So far, everybody understands? And so y prime is 1 over minus sine of y, which is minus 1 over sine of cosine inverse x. Right? Up to this point, you see how long does it take to write this line? It should take you less than half a minute to write this. You agree? Because I mean, there is nothing happening, right? Up to this point, less than half a minute. You can take, if you want, maybe another half minute to do this. Now, I apply sine to cosine inverse of x. And I ask myself this, what is cosine inverse of x? It's an angle. It's an angle. Are you with me, guys? It's important. You see, it's an angle of a right triangle. And if I apply cosine to that angle, I get adjacent over hypotenuse equal to x. So if I put cosine inverse of x, I can place here x and here 1. Triangles are similar. It's a right triangle. I can place here x squared and here I can place x. Doesn't matter, right? X and 1 is one triangle that accomplishes my goal. I'm only talking about ratios here, yes? So cosine inverse of x is just equal to, sine of cosine inverse of x will be opposite to hypotenuse. And what's opposite? By completing the triangle, it will be root of 1 minus x squared. Pythagorean Theorem. Do you remember how to prove it? We proved it in class. So that would be root of 1 minus x squared. And so sine of cosine inverse is simply root of 1 minus x squared. So the answer is minus 1 over root of 1 minus x squared. Very quickly calculate derivative of tangent inverse. We don't have time to waste. It should take you, well, I'll give you 3 minutes again, but it should do it in 1. Alan, wonderful. Will it help you if I scream at you in German? Yes, Carolina, good. Fast. Yes, good, wonderful. All right. Okay, this time. Now here is how you solve it. Y equal to tangent inverse. Tangent y is equal to x. Derivative of tangent is secant squared. If you forget derivative of tangents, it's just sine over cosine, okay? Always have multiple routes to the target. So secant squared y times y prime is equal to 1. And that means that y prime is 1 over secant squared. Again, if you noticed, I hope you do, is that it's just an obvious relation to geometry. Is that it's 1 over the slope of that you obtain when you differentiate tangent, because those are the same curves, yes? So this step should take you half a minute, right? How long can it take? Tangent of y is x. Derivative is secant squared y prime equal to 1. Y prime is equal to 1 over secant squared, and then you have 1 equal over 1 over secant squared tangent inverse x. Yes, that's what y prime equals to. Understood? Good. All right, guys. Some of you have 1,000-mile stare, like you have been through artillery bombardment or something, right? What has happened in Thanksgiving? So what is secant of tangent inverse? So again, I place the angle tangent inverse. Tangent inverse means if I apply tangent to this, guys, that's a very important step. Let me know if you understand it. That means apply tangent to me and you get x. And if it's in a triangle, applying tangent to it, you get x divided by 1 here, x and 1, right? And so the hypotenuse is the square root of 1 plus x squared. So if I apply secant and I square, if I apply secant, I get hypotenuse over adjacent. So that's how I get root of 1 plus x squared. And when I square it, I get 1 plus x squared. So the answer is 1 over 1 plus x squared. Do you understand how I did it? Is the entire thing clear? If not, by the way, here is a very quick comprehension check. Could you tell me, please, in terms of arctangent, this thing is arctangent of what angle? I took this angle here. You have this triangle. It's arctangent of what angle? Oh, I don't know what the number is. Why 30, 60? First of all, you're giving me degrees that we forget. No respectable person will use degrees. Like no gentleman used to exit his house without wearing a hat. Right? Don't give me degrees. A. Secondly, there are only x's and there are only x's here. How can you get this pi over 3? No. Where do you see pi over 3? We have 1x. What is this angle in terms of tangent inverse? Nassim, you're getting close. Look at it carefully again. I want tangent inverse. I want this angle to be described as tangent inverse of something. Of what? Tangent inverse means if I take tangent of it, I get opposite over adjacent. What's tangent inverse? Means apply tangent to me and you get opposite over adjacent. If you apply tangent to this guy, what do you get? What's the opposite over adjacent here? Yes, yes, Minkowski and Fu. Yes. It's a language thing. You see, this is 1 over x. Why? Because what is this? What does this entire sentence mean? Apply tangent, and tangent means opposite over adjacent. What's opposite? This is opposite. This is adjacent. Right? So if you apply tangent to this thing, you would get, because this is how you think. Apply tangent, and what should you get? Opposite over adjacent. So you get 1 divided by x. Good? You understand how that idea works? Okay. So you should, okay, now tell me what's the derivative of secant inverse, please, fast. Square root of 1 plus x squared. Well, the full derivative, what is it? Okay, so careful. Maybe you calculate something, but the full derivative. Come on, guys. You should get to 1 point very rapidly, and then from that point, another 30 seconds, I think. Should not be long. Time. Y equals to secant inverse of x. That's your first step. Apply secant, and you get x. Derivative of secant is secant y tangent y times y prime. If you forget derivative of secant, you can always recover it by noting it's equal to 1 over cosine. Okay, so you should always have ways to recover it. And then what? And then y prime is equal to 1 over secant y tangent y. Good. And then that is 1 over secant of secant inverse x, tangent of secant inverse x. And so let's calculate what they are. So I have secant inverse of x. That means that if this is the angle, the hypotenuse is x and adjacent is 1, because it's hypotenuse over adjacent should be giving me x. Any two numbers where the ratio will give me x would work, okay? So then completing the triangle, I get that the remaining side is x squared minus 1. Everybody understands? Guys, I see few people participating, so do you understand this idea? Do you see how I got this type of... Yeah, okay, confirm that you understand or that you think you get it. And don't dare to leave this office hours if you do not understand this. How do I get a triangle, Nassim? So you see that trigonometric functions are all related to ratios of the triangle. So secant is defined as hypotenuse over adjacent. So you take secant of this angle, whatever angle, right? If I take secant of this angle, hypotenuse will be x, adjacent will be root x squared minus 1. So whatever angle you take, there is a hypotenuse and there is an adjacent side. It's a right triangle, okay? And trigonometric functions take ratios, okay? So when I say, so if I assign this angle to be secant inverse of x, I can figure out what is tangent of secant inverse, for example, or any other trig function of this angle. Why? Because if this is secant inverse of x, it means apply to me secant and you will get the ratio equal to x, okay? But if I apply secant to this angle, I would have to divide the length of the hypotenuse by the length of the adjacent side, okay? Do you understand, Nassim? Right? And I could have written it as x squared and this as x, but the ratio has to be x. So it doesn't matter which you pick because you always consider only ratios. Every other triangle will be proportional. In other words, the same ratios will exist. So you might as well assign hypotenuse to equal x and adjacent to equal 1. Do you understand? And then because it's a right triangle, the remaining side is because the sum it's the hypotenuse squared minus adjacent squared gives you the square of the other side. So take the square root, and that's Pythagorean theorem. Are you with me, guys? Pythagorean theorem. You just it must be that the sum of the squares of the legs equals to the square of the hypotenuse. So if you have a leg and a hypotenuse, you can figure out the remaining leg, right? Good. So we have this triangle. Once I have this triangle, I can read every other trig expression. So for example, I have to figure out what is secant of secant inverse, and that's easy. That's just x. Secant of secant inverse is x, and tangent of secant inverse will be opposite over adjacent. So that part will be root of x squared minus 1. That's how I simplify it. You understand? Just because I have to calculate secant of this angle and tangent of this angle. The main thing to notice is this is an angle. Clear? Beautiful. Now, it's up to you. I'm not going to do it now to verify that derivative of cosecant inverse is minus 1 over x root x squared minus 1, and that the derivative of cotangent inverse is minus 1 over 1 plus x squared. Okay. Now, here are a few questions, guys. I will not have time to solve all of them. I will solve maybe 2. Okay. Maybe I'll solve a. Tell me what's the derivative for a, please. And afterwards, if you're interested, we can practice more in office hours or whatnot. All right, let's do it together. Guys, what's the derivative? It's just a tangent inverse squared, allows a tangent inverse squared. So what happens? You take the derivative of him and you get 2 tangent inverse and then multiply by the derivative of tangent inverse, which is 1 over 1 plus x squared. Very important function, by the way. Good? So we can write it as simply 2 tangent inverse over 1 plus x squared. Are you with me? You see, so we can do it slower if you want to once we are in office hours. Now, I don't have time, so please just do C. Find the derivative of h of t. You have 3 minutes. All right. What is the derivative? Come on. The derivative is pi over 2, Alan. Or maybe you are somewhere in an interesting spot, but do you mean the derivative is pi over 2? No, of course you. I mean, you wrote pi over 2. What's pi over 2? Pi over 2 what?
I don't know derivative. I don't know.
All right. Time is up. Here is the thing. You can take the derivative. Why not? Or you can think a little bit. Okay. And here is how we might think about it a little bit. So we have cotangent inverse of t plus cotangent inverse of 1 over t. Yeah? We have this thing. So let's look at a triangle. What is that about? So if I take this angle to be cotangent inverse of t, what does it mean? Help me please write the remaining sides. If this is cotangent inverse of t, where do I look? What do I write? T is adjacent and 1 is opposite. Thank you for T at the bottom and 1 here. Are you with me? And then the hypotenuse, if I don't really need it here because I'm only dealing with cotangent, but just for the humor of it, I will write 1 plus T squared. That's the hypotenuse. Agreed? Now, this angle is pi over 2. What can you say about this angle? What is that angle? Well, adjacent over opposite, right? If I 1 over T, I see a 1 over T here. Adjacent over opposite. So what is this angle over here? This angle over here can be written as cotangent inverse of 1 over T. You agree with me? Why? Because if you apply cotangent to this angle, you would take adjacent over opposite. This becomes adjacent. Yes? Now, tell me, please, what's the sum of those angles? Cotangent inverse of T plus cotangent inverse of 1 over T. What's the summation? Well, cotangent inverse is be careful. So you can have many representations of this thing. So I can write this as tangent inverse of T. This is also tangent inverse of T. So maybe that's what you meant, Christian, right? Not tangent, but tangent inverse. And you said X, but I think maybe that's what you meant. And if so, that's great observation. So what is cotangent inverse of T plus cotangent inverse of 1 over T? It's equal to? Yes, James, you are absolutely correct. That's a good observation. But in particular, what does it equal to? Because what do the angles add up to? There is one angle we know. This angle is pi over 2, right? We think of it in radians. This is pi over 2. Yes. Yes, Carolina, and yes, Fu. You see, they add up because the angles must add up to pi. We already have, this is pi over 2. This angle is pi over 2. And then the remaining angles must add up to the same amount. I do not know what each individual angle equals to, but the sum must equal to the red angle because together they are equal to pi. Good? So the answer is that this is equal to pi over 2. And what's the derivative of that expression? So now if I take the derivative of that expression, what do I get? You see, Alan, why I asked you why you got pi over 2. I mean, I was not sure where you got it. Maybe you were on the right track and maybe not. So what's the derivative of cotangent inverse T plus cotangent inverse 1 over T? What do we get? Come on, guys. Don't fry your circuits on me. You can do it. Tell me what do I get. And where did you all disappear? You are hiding your faces in shame? Hello? Can you still see me? Internet connection. I got this statement that it's unstable. Can you see me? You can see me. You can hear me. Yes, it works. I hope it does. Thank you, Christian. So what's the derivative? Exactly, it's just 0. It's just a constant. So it's just the derivative of pi over 2, which is 0. This looks complicated, but this is nothing more than a constant. Do you understand? So James, what you observed was beautiful, that you notice it's tangent inverse plus of T plus tangent inverse of 1 over T. But what was useful in this situation especially is to see that it's a constant. Okay? Again, guys, my point is when you understand what you're reading or what you're talking about, the entire thing is very simple, very often, right? I mean, you might have tried to take the derivative and you might have been successful, but you're wasting your time. You understand? If you realize what something is talking about, you're not just pushing symbols, you actually can go around a lot of complications and know the solution. Okay, so that's how you solve. The meaning, not the symbols. Look at the symbols, but they are only there to record the meaning. Get the meaning, figure out the answer, put it back in symbols. Good? How are you, Carolina? Good? You're doing well?
Yeah, my sister called, so I missed that last part of the explanation.
Which part? Can I help with something? Is it clear?
I feel bad to hold. I was going to ask in office hours, but how did you reason your way through the last step?
How did I? Well, that is pi over 2.
No, I got pi over 2.
How did I reason what?
After that, you said
The derivative of a pi over 2 is constant. So the derivative, this thing is identical to pi over 2. It's always equal to pi over 2. What's the derivative of pi over 2? It's the derivative of a constant.
Okay, got it.
So this function looks like it involves variables, but it's like 5x minus 5x. You understand? It's canceled. It's canceling to a constant. That's the point.
That's how you got 0.
Okay, great.
Right.
So we are moving finally to integration. Okay, so this we can do more of in office hours if you'd like. I'm gonna stop this recording.